Selamat sejahtera and hi everyone. This is our project presentation. We are from Group 1. Our project title is Roller Weeder Machine. First, introduction of the project. Weeding activities is one of the significant intercultural tasks which control undesirable plants between the columns which expend more fertilizer and decrease the harvest yield. There are many tools that using to remove weeds. One of the tools is roller weeder. Roller weeder is a simple tool that helping gardeners to remove weed easily. It is also a soil consolidation. It is light in weight and easy to use. With simple pushing and pulling operation, the roller will help in removing weed and loosening the soil. Next is project breakdown. Weeding is one gardener job that nobody looks forward to. Weeding involves bending down low and spending an inordinate amount of time trying to pull out unwanted plants from your garden beds. The awkward position and repetitive motions that go along with weeding tasks will wear out physically. Luckily, gardeners are not required to weed their garden by hand, and there are weeding tools available to us that can take a lot of stress and frustration out of routine weeding tasks. Roller weeder is a simple tool that removes the weed by rolling the tools while working. When pushing the roller weeder, its blades will start rotating and pull out the weed on the ground. The weed can remove easily in shortened time by using roller weeder. For the objective of the project is to perform the design process of the product by using SolidWorks, to analyze the product properties by using static simulation in SolidWorks, to make improvement on the design of a product based on the static simulation result in SolidWorks. Then for the scope of the project, SolidWorks 2021 software is used in design and simulation of roller weeder. Features are applied on the cover, shaft, and circular blade of roller weeder. Force applied on the roller weeder is 1000 Newton. Estimate wheel size is 4 mm. The main material for roller weeder is steel.
Next, I will present the materials and methods. In our project, the steel will become our main materials for design the ruler weight because of its number of properties, which is hardness, toughness, tensile strength, yield strength, erosion, fatigue strength, corrosion, plasticity, malleability, and the creep. Then, these are the flowchart of the design process of the ruler reader. In the flowchart, we can saw that we start with identification of needs of agriculture industry. Then we get the definition of the problem in removing weed. Then we propose in design concept. Then we start CAD modeling. Then we choose the suitable materials. After that, we will start our simulation test. If the simulation tests are not certified, we will repeat the step from the CAD modeling until the simulation tests are accepted. Then will documentation and presentation and end with our project. Firstly, the design concept will generated by sketching manually as the diagram show that our Google weed are separated into different parts which holder, roller, shaft, and cover. Then the roller is assembled by the blade and the circular plate. Every part will be drawn to ensure the part can be assembled become a weed ruler, and the dimension of the every part also can be decided in this project process. Next, the process of modeling design will be conducted using SolidWorks software. And the diagram shows that the user interface of the SolidWorks 2021. The sketching layout will be used for drawing, and the smart dimension is used for defining the dimension of the sketching. Next, I'm showing the part of drawing of the of every part of Google readers and create using SolidWorks. First is the Hogger. The Hogger we are create with the height of 650 mm, wide with 250 mm, and a diameter of 50 mm. Then the shaft with a length 280 mm and with the diameter and 20 mm. Next is the cover with length of 250 mm, wide 250, height 250, and thickness of 5 mm. And next is the blade, which is length of 220 mm, wide is 50 mm, and thickness with 3 mm. And last is the rulers with diameter 200 mm and thickness 5 mm. After that, finish the part drawing. The part will be assembled by a SolidWorks to combine all the parts into ruler reader. As the diagram show that we insert all the parts in the assembly layout, then we combine using SolidWorks function of make to combine all the parts become a bigger ruler. As the diagram show that we from a before with a part and assembly become a big ruler. And these are the diagram of the assembly drawing of the ruler wheel. Next is the exploded wheel drawing of ruler reader. Next, in the diagram, by observing the exploded wheel, we can know that our big ruler reader are made by how many number of parts and could combine become our ruler reader. Then in the simulation, we are using insert all the parts with a bacteria of alloy steel. The yield strength of the alloy steel is 620 m per mm square, and the features are applied to the cover, shaft, and the circular plate of the ruler reader. Then the force are applying on the ruler reader as is 1000 N at the holder and the blade. The estimate width side we are using 4 mm, and the standard mesh is used before running the studies.
My name is Jung Jia-jun. Now I will present our group project result and discussion. For the first result of static simulation on stress, the maximum stress is about 422,000 megapascal, while the minimum stress is 0 megapascal. Since the maximum wall meter stress is no exceeded the yield strength, which is about 620,000 megapascal, the part will not break under the force load 1000 Newton. For the first result of static simulation on displacement, the maximum displacement is about 3 billion millimeter, while the minimum displacement is 0 millimeter. Next, for static simulation on strain for first result, the maximum strain is 1.272 and minimum strain is 0. Then, the first result of static simulation on weld check plot, we calculate the weld is 0.10613 millimeter, and estimated weld size for us is 4 millimeter. Since there is no attention for welding, we can use 1 mm weld size based on the 0.10613 of calculated weld. In the second result of static simulation on stress, the maximum stress is about 8,121.092 megapascal. Minimum stress is 0 megapascal. The yield strength is 620 megapascal. Since the maximum wall meter stress is not exceeded the yield strength, the part will not break under the force load 1000 Newton. The maximum wall meter stress is decreases. For the second result of static simulation on displacement, the maximum displacement is about 7 million millimeter and minimum displacement is 0 millimeter. The maximum displacement is decreases. For the second result of static simulation in strength, the maximum strength is 0.014 and minimum strength is 0, and the maximum strength is decreases. Lastly, the second result of static simulation on the weld check plot is same as the first result of static simulation on weld check plot. For discussion, from the second result, the maximum wall meter stress is decreases. Wall meter stress is a value used to determine a given material will yield or fracture. It is mostly used for ductile materials such as metal. The wall meter Yield criterion state that if the wall mixture stress of a material under load is equal or greater than the yield limit of the same material under simple tension, then the material will yield. Therefore, the roller window will not break under the force load 1000 Newton as the maximum wall mixture stress is nor exceeds the yield strength. The design of the roller window improved by reducing the maximum wall mixture stress, displacement, and strength.
The project's overall conclusion is that an analysis was conducted to determine the specifics that needed to be completed. We have completed the actual roller weeder design and chosen the materials for the project's component part using SolidWorks. The design of the roller weeder's actual appearance was created with some input from literature survey work and references. To sum up, once the project was completed, we were able to sharpen our SolidWorks design skills and apply finite element analysis to the final product. With the help of the group members' excellent contribution, the product goal was achieved. Alloy steel was used because it respects the condition for the deformations under the admissible value. Next, recommendations. The selections for the material affects the result of stress, strain, and displacement. We would like to run the analysis with variety of materials in project components to achieve more accurate results from finite element analysis compared to actual wheat roller. The improvements that we have done for the actual product is increase the thickness of the blade from 3 mm to 10 mm. Besides, we can apply the AISI 4340 steel to replace alloy steel. This is because the yield strength of AISI 4340 steel is much higher than the alloy steel. Thank you.